Hello children. So welcome to today's class. So today's class is about something what is a very essential and very useful. Till date we have gone through a lot of things by this stage. You might have learned the numbers when you started reading. Your parents definitely have taught you to count the objects. When we count objects, with what number we started? We started with the number 1, 2, 3. Then gradually we gone for more. Okay, suppose now also I will tell, go and find the number of students present in the another class. So what will do at then? You will go and find the number of students are sitting at there. You will start counting them. You will count like 1, 2, 3, 4 and so on. And when you find such numbers are there, you need to present them and you will tell a number. So the numbers what we used for counting purpose, we learned fast. We start our number system to know the numbers from counting numbers first. Okay, so when we learned the numbers fast, we came to know the counting numbers. So what are counting numbers? The numbers we used for counting purpose are called as counting numbers. We use them like this: 1, 2, 3, 4 and so on. These numbers are used for counting purpose. So they are called as counting numbers, but we give them a different name as they are called as natural numbers. We call them as natural numbers. Now these numbers are started with 1 and moves endlessly. There are infinite such numbers. They are all called as natural numbers. Now what is the least natural number? From here we can know. As the number starts from 1, we can say the least natural number is 1. So 1 is called as the least natural number. Can you say what will be the greatest natural number at here? Can you move to the greatest natural number? I think we cannot say. Okay, there is no greatest natural number, because whenever you will tell such natural number, the next I will add 1, you will go to the next natural number. So there will be no greatest natural number then. So the first number what we came into our life is a counting number or natural numbers. It starts with 1 and moves endlessly onwards. But after learning the natural number, we feel that natural numbers are not always helpful to us to represent all things. For example, let me find there are lots of fruits in a basket. Suppose there are 10 fruits in a basket. There is a basket where it is 10 fruits. Okay, let me tell it is there are 10 fruits in the basket. So there are 10 fruits. So the 10 fruits are there in basket. We counted them as a 10 fruits because we count by the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 fruits in the basket. But if I'll take all these fruits from this basket to another side, so what will be the left in the basket? To represent such situation, we used to define another number. But can you find the number system, the natural numbers will help to describe such situation? If suppose I will take all the fruits to another side, so how much will be left? Can you count them as a 1, 2, 3, 4? No, there will be nothing left. And that nothing has to be represented by some number. So when we require some number to be represent this nothing situation, we developed a new numbers and it is called 0. Okay, so when we required 0, then we started thinking these all numbers 0, 1, 2, 3, 4, all numbers also represent whole number of things. That means when we represent some goods, some quantities, some things, we use some whole numbers. And whole numbers are all natural numbers along with 0. So we start with 0, 1, 2, 3, 4 and so on. These are all called as whole numbers. These are all called as whole numbers. They are used for used for expressing the numbers, whole number of quantities. But after we find this whole numbers, we again see this natural numbers are also there inside this whole number. That means whole numbers also contain the natural numbers. If all these natural numbers are collected and kept in a set, the set is called as natural numbers and the set denoted by the letter n. Similarly, when all the whole numbers are collected and kept in a set, the set is called as whole number set and it is denoted by W. W, we definitely can understand this comes from the word W, whole number, and natural numbers n comes from this word natural. Okay, so and if you observe that all these whole numbers definitely contain these natural numbers. So here we can find this natural numbers contains all the whole numbers. So if you can write it as n, this will be W. And outside this n and inside the W, what is left? That is 0. That is 0. Okay, so today's objective, these things we have already learned. This natural numbers, whole numbers, all these things today we have already completed. So our purpose is to discuss today what more we are going to learn in this new number system. As earlier, we have already completed some portions of this number system. So let us learn little more on this number system. So by today's class, we are going to, after this today's class, you will be able to know the extent of this number system beyond this natural numbers, whole numbers. Okay, and you can also know to what is integers, what is rational numbers, what is irrational numbers. We will distinguish the rational numbers and irrational numbers from natural numbers also. This is whole numbers, natural numbers, integers, all these numbers has to be distinguished. Okay, so let us go. Okay. After we completed this whole number and the natural number, we move to the another numbers. For example, when we operate the whole numbers, suppose I have 2. When I add 3 to it, I find 5. Here 2 is a whole number. 3 is another whole number. When I added both the whole numbers, I find one more whole number. So addition of whole numbers, any two whole numbers leads to one more whole number. It's okay. This gives us the idea that whenever we add two whole numbers, we always find another whole number. But does it satisfy to the subtraction also, to the difference also? To know that, let us go to the next. Okay, so let me subtract. Let me rub this portion. Suppose I have 5 is a whole number. I want to subtract this 2 from this whole number. So when I subtract 2 from 5, I find there is 3, which is also a whole number. But if I want to find 2 minus 5, can it be possible in the whole number? Can I take 5 objects from 2 objects? Definitely I cannot take, but this situation can be expressed in a different way. To express this situation, we need to develop one more number system. And that's why another number system came into existence, that is called integers. We know already it is integers. So what is integers? Integers is a collection of all natural numbers, then 0 along with all negative of natural numbers. So when we write natural numbers as 1, 2, 3, 4, 5 and so on, when we add 0 to it, and again we'll find -1, then -2, then -3, -4 and so on. These all negative of natural numbers along with 0, they all put together makes a new set which help us to represent such type of situations. Okay, they are called as integers. They are called as integers. So integers help us to detect the difference or the operation on whole numbers. All types of operations on whole numbers. Okay, so we can find this set of integers is represented through a letter Z or sometimes we can represent also by I. I definitely we very simply you have to understand I comes from this word integer, but Z also is used for a set of integers. Can you say from where this Z terms come? Z comes from a German term. It is called Zehlin. Zehlin. Zehlin is a German term. This means to count. Even if we are not taking this all numbers for the counting purpose, but still Zehlin is a term used to count. And from this term Zehlin, it's a German term, from this Z is came from. Now we came into existence, this integers is a set of integers. All the numbers, natural numbers are there, 0 is there, that means 0 along with all natural numbers, the whole numbers are there, and negative of natural numbers are also there, which help us to detect all the set of integers. So set of integers, can I find it here? What is the least number integer at here? As we are finding the least natural number is 1, least whole number is 0. Can I find least integer at is what? We cannot find the least integer at here, because this is extended endlessly towards this negative direction. Similarly, we cannot also find the greatest positive integer. That is also extended endlessly. So we are seeing the in between this. And all these situations can be presented, all these numbers can be presented in the real number line. That's why they are called as real numbers. Let me find what is real, why it is called as a real numbers. The numbers what we discussed already, they are all called as real numbers. Why they are real? Because we are able to present this such situation through a real number line. When you present such numbers in a real number line, this is a number line. I kept 0 in between, and with equal distances I have taken points 1, 2, 3, 4, 5 and so on. 1, 2, 3, 4, 5 and so on. Here suppose it is -1, -2, -3, -4 and so on. This is a real number line. And all the numbers which are possible to present at here, they are called as real numbers. They are called as real numbers. So now these integers are real numbers. Integers help us to detect the properties of the whole numbers. But now again we'll think about, does this integers fulfill all our needs? No. In such case, we can extend this any part of this integer, because all these parts are equally divided. We can extend any part of it. Suppose let me take it here. Any one part I will extend. Suppose this is 0. This part is 0. I have to extend it 10 parts. I will split this 0 to 1 between 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. So in between 10 parts this is 0. I will write it is 1. So from 0 to 1 I have extended this part, and I divided this part again into 10 equal parts. Now this part I can write it is 0. So it is totally, this part is this. So I will write it is 0 by 10. This will come as 1 by 10. This out of this 10 part, one part I have selected. So this will be 1 by 10. Again I will come it is 2 by 10. This will be 3 by 10, 4 by 10, 5 by 10, 6 by 10, 7 by 10, 8 by 10, 9 by 10, and this one is represented as 10 by 10. So when I represented all these numbers, I find the such type of numbers are not there inside these integers. That means there exist a types of different type of numbers which are not included in integers. That's why we created a new number system. It is called rational numbers. So what are rational numbers? Now we decided the numbers which can be presented in P by Q form, where P and Q both are integers. Okay, so another new number system we developed, that is called rational numbers. Rational numbers. These rational numbers are the numbers which are represented, or I can write any number which is represented by P by Q form, which is represented by P by Q form. What this P and Q are? You can see at P by Q form I have written all these numbers in fraction form. So this P by Q form, what this P and Q are? The P and Q has to be, P and Q are integers. P and Q are to be integers. And only P and Q are to be integers. We can also keep an Q should not be equal to 0. And Q is not equal to 0. When P and Q are integers and Q is not equal to 0, and when we need to express this P and Q in standard form, we have to find the HCF of P and Q. That means the highest common factor between P and Q is equal to 1. Even if we will not write this highest common factor, it will be an equivalent fraction, but it will be okay. But P by Q, when I write in the rational number, the HCF of P and Q should be equal to 1. Okay, so such type of numbers, any number which can be represented in P by Q form, where P and Q both are integers and Q is not equal to 0, is considered as to be a rational number. So now we come across all the rational numbers. Now think about, between two numbers, these two integers I have taken, I have divided into 10 equal parts, and each part I called as a rational number. But again we can think, can we further divide any part of them and we can again divide into 10 equal parts, and can I do it? Yes, it is possible. We can divide many parts, not exactly 10 parts, we can divide into many parts. And such type of situations can be created that rational numbers give some more rational numbers in between two given. That means if I tell two rational numbers are there, I can find some more rational numbers between that. Let us find. So let me rub this part. On the number line, when I tell it's a number line, now I detected this is a rational number A, suppose. This is another rational number B. There are two rational numbers A and B on the number line. I symbolize the numbers as A and B. You can take any numbers at here, but I symbolize the general form as A and B. Now A and B are two rational numbers. I take A and B are two rational numbers. Are two rational numbers. And what more condition is given? A is less than B. How do you know A is less than B? Because A lies left side of the B. So as we go left in the direction of this number line, we find the numbers are coming lesser. And we go to the right side of the numbers, you will find the numbers are bigger. So B is definitely more than A. So here we can find A less than B. Since A less than B, A and B are two rational numbers. Now how to find, how to develop or establish one more number between A and B? So for that, I can go A less than B is a condition given. Now let me take these conditions. I will write as A less than B. Then I can add A on either side. I will find A plus A is definitely less than B plus A. So what I did at here, by the law of equality, I added A on either side. And by this process, what I get? I got 2A. A plus A becomes 2A is less than A plus B. Here I have got B plus A, I turned into A plus B. This is which property? This is a commutative property. A plus B and B plus A both are same. So this is a commutative property. So by this property, what I get? 2A equal to A plus B. If 2A is less than A plus B, 2A is less than A plus B. As 2A less than A plus B, now can I write 2A by 2 is less than A plus B by 2. So in this way, I find divided 2 on either side. This is also by law of equality. So I can divide same number on either side. The equality or inequality will never change. So 2A is less than A plus B. 2A by 2 is less than A plus B by 2. So what it gives then? It gives then A is less than A plus B by 2. Then I got A is less than A plus B by 2. So let us make it a statement and keep it here. I find A is less than A plus B by 2. That means A plus B by 2, I found another number which is more than A. Now let me go to the next part. Again I will come to the given condition. I have A less than B. Then again I will add B on either side of this. So A plus B is less than B plus B. This gives us a plus b is less than 2b. Now b plus b becomes 2b by the definition of addition. Then I will divide a plus b by 2, which will be less than 2b by 2. By the law of equality, I divided 2 on either side. And what I find? I find that a plus b by 2 is less than b. So let me make it a statement 2. Now I was already get a less than a plus b by 2, and now I got a plus b by 2 is less than b. Now combining the statements, I will get finally, hence a is less than a plus b by 2, which is less than b. That means if a and b are two rational numbers are given, we can find a plus b by 2 is another rational number which lies within this a and b, which is more than this a and less than this b. But here this process doesn't stop. We can also find a plus b by 2 lies within this a and b. Suppose here it is a plus b by 2. But if I find again a and a plus b by 2, I can find still more one number at here. If I can use these two numbers again I can find one more number at here. So if I go on adding and dividing by the 2, I will find more numbers at here. So here this process steps us or gives us the idea about that there exist infinitely many rational numbers between two given rational numbers. So let us, what we learned today? We learned that real numbers are, under this real numbers, we learned first natural number. Then natural numbers are the numbers used for counting purpose. We learned natural numbers which are used for the counting purpose. They are 1, 2, 3 and so on up to, represented by the letter n. Next we learned about the whole numbers. Whole numbers used for the objects we present or things we present in wholly. So it is the whole numbers. Then next we learned about the integers. Integers which help us to know. Integers are help us to know about the properties of the whole numbers. Then next we learned about rational numbers. Rational numbers are those real numbers which can be presented by p by q form. Okay, these numbers we have recapitulated. This is natural number indicated by n. This is a whole number by w. This is integers by z. And this is rational numbers by q. Rational numbers are represented by letter q. Why this q? Q stands for the term quotient. From the term quotient, this word letter q comes from. Okay. So now if I tell all natural numbers are there inside the whole numbers, and all whole numbers are there inside the integers. All integers are there under rational numbers. Now can you find, I will ask some questions to you. Can you answer me some questions? Let me ask some questions to you. Does all whole numbers are natural numbers? Will it be okay? All whole numbers will be natural numbers? No. Because there are whole numbers lies which are not the natural numbers. What is that? It is 0. So 0 is such a whole number which is not natural number. But except 0, all other whole numbers are considered a natural number. But since 0 we cannot consider as whole number, we will write all whole numbers are not natural numbers. But rather we can say all natural numbers are whole numbers. Now come to integers. All whole numbers are integers. But we cannot say all integers are whole numbers. Similarly, all integers are rational numbers. But we cannot say all rational numbers are integers. But can you say how integers are rational numbers? Can anybody ask me how integers are rational numbers? Suppose the integer I will write it is 2. How I will define it is an integer, how this can be rational numbers? Because I can write 2 as 2 by 1. Because 2 is written as 2 by 1, so it is 2. So this is p by q form where p, q both are integers and q is not equal to 0. So when p and q, it is any integer is represented as p by q form, so it becomes a rational number. So 2 becomes a rational number. I can write 2 this, also this 2 in the form, I can multiply 2 Here it will be 4 and this denominator is multiplied with 2, it will become 2. So this 2 again becomes 4 by 2. Here this 4 by 2 is also rational number. It is representing the same 2. And these are called equivalent rational numbers. Actually the correct form is 2. But we can also write in 2 by 1 and 4 by 2. Both the numbers represent the same thing, it is 2. Okay. So by this process we find every integers can be expressed as rational numbers. So all the integers are rational numbers. But can I say all rational numbers are integers? No, because there are numbers, rational numbers, which are represented by p by q form, but the denominator is, since it is not 1, so we cannot write it is in integers. Okay, so that's why natural numbers, whole numbers, integers and rational numbers, we discussed all about this in real numbers, but real numbers are not finished up to this much. And every numbers cannot be represented up to this rational numbers. We should go beyond these rational numbers. And what are more there in rational numbers, we will see later. Okay, so let me ask some questions to you. Can you find some rational numbers? As we discussed, there exist infinite rational numbers between two given rational numbers. So can I find, let me rub this. Okay, find two rational numbers. Find two rational numbers between 3 and 4. Find two rational numbers between 3 and 4. Can I find two rational numbers between 3 and 4? How will you answer? How you will present two rational numbers between 3 and 4? Because we know 3 is a rational number because 3 is an integer, so it's a rational number. 4 is also a rational number because they are presented in rational number line. So, and as I know that there exist infinitely many rational numbers between 3 and 4, so how we can find two rational numbers between this 3 and 4? To find these two rational numbers between 3 and 4, we can find by 3 plus 4 by 2. And 3 plus 4 by 2, I will find it is 7 by 2. So now 7 by 2 is a rational number which lies between 3 and 4. But this is only one rational number. So let us make it as x1. I will write it as x1. Now 3 and 4 are the numbers. 7 by 2 lies within this 3 and 4. Let me add again 4 plus 7 by 2. So 4 is a rational number. 7 by 2, which is new rational number I got. Then I added both of them and I divided by 2. When I divided by 2, I can also multiply half into it. So I will find it is, so 4 plus 7 by 2, I will add it here now, 1 by 2. So 2 will be here. So 2 into 4, it is 8 plus 7. So this gives now 15 by 4. Okay, so here this 15 by 4 is another rational number which I will represent as x2. Now I find two rational numbers x1 and x2 between this 3 and 4. So hence I can write is 3, then next number is 7 by 2 and next number is 15 by 4 and hence it is 4. So these are the new rational numbers I find between this 3 and 4. Okay. So some questions I will give to you. So you will practice today. So basing on this, put inserting rational numbers between rational numbers, we can also find two rational numbers, we can find three rational numbers, we can find infinitely many rational numbers. But if it is the given to put 50 rational numbers between two given rational numbers, how it will be detected? Let us go for that. Okay, let us find some more rational numbers between two given rational numbers. Okay, so I will tell, let us find 50 rational numbers between 1 by 2 and 2 by 3. If you need to find 50 rational numbers between 1 by 2 and 2 by 3, how it is to be find? 50 rational numbers. So my question is to find, so I will find 50 rational numbers, 50 rational numbers, 50 rational numbers between 1 by 2 and 2 by 3. Suppose there are two numbers 1 by 2 and 2 by 3 given. 1 by 2 is a rational number. 2 by 3 is another rational number. So 1 by 2 and 2 by 3, there are two rational numbers. I have to insert, I have to find 50 rational numbers between this 1 by 2 and 2 by 3. How it is to be done? So let us learn now. So I will find, so as the process I know, a plus b by 2, I can go by this process. But if I'll add 1 by 2 plus 2 by 3 and divide by 2, so it will take so long time to find. So there are another method. So let us use this another method to find. So in that case, I will find this denominator of this two rational numbers. The first rational number is 2, denominator is 2, and the second rational number denominator is 3. So let me make them equivalent fractions. So to make them equivalent, I will find the LCM of this 2 and 3, and it will be 6. So LCM of 2 and 3 is 6. So I will try to convert this 1 by 2 has denominator 6. So I will write it here now. 1 by 2 equal to, so multiplying 3 at here, so I will find it is 3 by 6. Does it 1 by 2 equal to 3 by 6? In the same way, I can write 2 by 3 is equal to, so to make 6, I have to multiply 2 here. So in order to multiply 2 at here, to make it equivalent, I have to also multiply 2 to the numerator. So I will find it is 4 by 6. Now 1 by 2 I turned into 3 by 6. 2 by 3 I turned into 4 by 6. Now this 1 by 2 and 2 by 3 has turned into 3 by 6 and 4 by 6. Okay, now when the denominators become equal, 6 and 6, let us find the difference in the numerator. It is 3 and 4. So what is the difference between 3 and 4? It is 4 minus 3 is 1. That means the difference in the numerator is 1. But I require 50 rational numbers between. So let us multiply 51 to both the numerator and denominator of each rational number now. So I can write 3 by 6 into 51 at here. So I will find it here. 3 1s are 3. So 3 5s are 15 at here. And similarly at here, it will be 6 and 3. So 306. So 153 by 306 represents this 3 by 6 and 3 by 6 represents this 1 by 2. Similarly, in the same manner, 2 by 3 I can convert as 4 by 6. I have already converted into 4 by 6. So now 4 by 6 I multiplied 51 it and 51 to the numerator also, because to make it to equivalent. So what it gives at here? It gives 204 divided by 306. Now this 4 by 6 I turned into 204 by 306. And this 3 by 6 I turned into 153 by 306. Okay, now if I'll write 50 rational numbers between that, I have to find, so 153 by 306, which is less than 154 by 306, which is less than 155 by 306, and so on up to, I will write the last one is 203 by 306, and last one is here 204 by 306. Now you can see, when I write 153 by 306, this number represents my, it is 1 by 2. This is 1 by 2. When I write it is 204 by 306, this represented as 2 by 3. Now between this 1 by 2 and 2 by 3, I inserted 50 rational numbers between that. So by this process, we can find any number of rational numbers between two given rational numbers. Okay, so let us keep this class at here. So I will give some questions to you, what we taught today. Basing on that, you will practice. We'll continue the class on the next slide. Okay, thank you.